one of the things that was interesting about writing a book about programming, which necessarily is going to represent my own views about programming, right? I'm writing the book. And those views are completely driven by the environments I've been in, whether that was Princeton or Microsoft or Sucker Punch. And writing the book kind of forces me as an author to confront the question of how many of those beliefs are only true in the limited experience that I've had, right? Like what some of these are clearly true for the environments I've been in or the environments I've created, but not elsewhere, right? And the same's true with like performance reviews, right? Like we can rebuild our process so that it's about personal growth and about your journey. This makes a lot more sense if you've got people that are going to be at your company for 5 years or 10 years or 15 years than it does if you're churning people through, right? Absolutely. Like if people are going to be there 6 months and then move on, it's like, you're not going to worry about this, right? You're lucky if they even hit the performance review cycle, right? So there are a lot of companies that are like that,
that's
right?
True.
So you have to do it differently, right? And I think that's true for a lot of stuff. Like we have really good retention at Sucker Punch. We just don't have a lot of turnover. And that enables us to do things really differently as a development organization because we all have this shared background, right? I mean, we've all been through tough times together and come out the other side and had success. And so there's this really, really deep well of trust and, a bond between the people on the team because of all this stuff. And so you can run the company with a lot more autonomy for personal decision-making when everyone is part of an organization like that, right? I mean, you just can. And so like I give advice about, people ask me how to run a programming team. I'll say, well, this is what you should do. But the truth is that advice works really well for environments like Sucker Punch, where, we can be incredibly selective about who we hire and people stick around for a long time and we're working on long life cycle projects and so on. And if you change any of those, then suddenly a lot of the advice or a lot of the ways we do things are suspect, right? They're not going to work as well. It turns out that I called the book The Rules of Programming. It's kind of a joke because that's actually what we call it the rules inside of Sucker Punch. And it's kind of tongue in cheek. They're not actually rules. It's not like anyone's going to come around with a ruler and slap you on the wrist for not following them. They're guidelines, right? You interpret them. You have to understand them. But I call the book The Rules of Programming because it's a fun title. It turns out that programmers don't like being told what to do. Who knew, right? And so I'm like, okay. And I understand going in that, some of these rules are really specific to the Sucker Punch environment or companies that are set up like Sucker Punch, and they're not going to make a mistake. They're not going to make sense somewhere else, right? Let me give you an example. So one of the things about games that makes games fun to work on is there really isn't backwards compatibility for the kinds of games we build. We build these single player games that are packaged and sold. They're big games, right? We spend a lot of time, a lot of money making them, but they're packaged up and sold, every so often, every few years. And once that game's done, we're kind of done with it. We're moving on to the next game. So we don't have to worry about, what about backwards file compatibility, right? What about all the scripts people have written against our old product? How are they going to run in the next version? We don't have any of that stuff, right? It's all white sheet of paper every single time. We build it on top of the last game's technology, right? It's not like we throw everything away, but we're not constrained. And because of that, it means that we can be way more aggressive about changing things than you can if you're working, back office at Deutsche Bank, right? You can't just change how the back office works. You don't want to drop somebody's deposits, right? That would be bad. Probably would not go over well, right?
First, you have to learn COBOL anyway.
Yeah. So for us, we can change things. And so that leads to a different kind of engineering mindset, knowing that we can make big changes whenever we want to. And then that's kind of a ripple, right? Because it's like, okay, well, how would you build your code if you knew you could change it all the time, right? It's like, well, or if you thought you were going to need to change, it's not like we change things just to change things. We change things because our first version of something sucks, right? And so we can't ship that. We're going to have to change it to something else. And guess what? Try number 2 also sucks. It's like try 3 or 4 or 5. Finally, it's okay, right? Well, knowing that, having seen that over and over and over again during Sucker Punch's history, we have to write our code and our systems in a way where we know we're going to change it. And so everything in the whole ecosystem has to support that, because we know the code's going to change, right? And so a lot of the things that we hold as kind of the core tenets of Sucker Punch development, like keeping things as simple as possible, come out of that basic idea that we're going to need to replace stuff, because our first guess at what was going to be fun for the player is going to be wrong, because it's always wrong. Mm-hmm. And it's only after we see why it's wrong and do another version, find out why that one's wrong, that we get to something that actually works, that we can make great. So, because it takes, I don't know. Thing about the people don't realize about playing games, and maybe other games companies do this differently. Maybe other game companies are full of people who can predict the future better than I can. But like, people see something at the end that's pretty good, and they don't see all the versions of it that were really bad that lead up to that. So, we run the company around making sure that we can run through 5 versions of something before we ship something to customers. And that changes everything about how we do stuff. We worked really, really hard for a long, long time on Ghost of Tsushima. It took like 6 years for us to do start to finish, which was a long time. And I was a little bit tired by the end of it. So I switched to half-time. I backed off to only working 20 hours a week, which was honestly a lot less than half-time. But 20 hours a week is what I'm doing these days. And I can help at that level. I can still be helpful at Sucker Punch, but I'm a little bit less emotionally caught up in the ups and downs of the project. And so I'm enjoying myself a little bit more. And I did that. So I still have my hands in it. I don't know that I could give it up, but now I have time to do other things. So like I have a little game project I'm working on my own right now. Mm-hmm. We'll see whether that actually ever sees the light of day. But I spent a couple years after I switched to half-time, writing a book about programming, which, well, here's the story. It's called The Rules of Programming by Chris Zimmerman, available wherever you buy books. And the idea of it, the reason I wrote it, was that we at Sucker Punch and at Microsoft before then have always had a model for building our staff where we hire a lot of really junior programmers, a lot of people that just graduated from school, or maybe they've been working in the industry, maybe not the games industry, just programming of some sort for a couple of years. Because in our experience, if you take someone that's motivated and smart and willing to learn, they can learn how to do the game programming part of it. And that's not really usually a challenge. The hard part is finding the people that are motivated and smart and willing to learn. But that does leave us in a position where we have a lot of 22-year-olds coming in. And they're smart and they're motivated and they're willing to learn, but they've got a lot to learn, right? They've programmed in college, which is different than programming professionally. They worked on small projects that were, write and throw away, and they were done by a single person, maybe 2 people, and it was for some, artificial problem that nobody cares about, right? And so, and they were taught by people generally. A lot of people that are computer science professors have been in academia their whole lives, right? And so they haven't even had the experience of working on a 50-person team for 5 years to know what it is they don't know, right? And so a lot of freshly minted computer science graduates do know how to program, but they don't know how to program at scale, right? They know how to write a loop, but they don't know how to build a big product with a bunch of other people, or how to work on a code base that's been evolving for 20 years. And they end up making the same mistakes over and over again, or at least that's what it felt like. It'd be like you'd have a new person come in and they'd make a mistake that you'd seen other people that were in a similar situation make before them, and be like, why do people keep doing this? And so, like the example I'd use is that I think a lot of 22-year-old programmers have heard over and over again through their academic training that abstraction is good and generality is good, that a general solution to a problem is always better than a specific solution to a problem. You want your code to be as general as possible. They've deeply internalized this. And so when they come and work at Sucker Punch, a very common mistake for new sucker punchers to make is to take some small problem that they have to solve and write a very general solution that it solves that small problem as like a subset of all the things it can do. And it turns out we really don't want them to do that. I said earlier that we are going to change our code a lot, right? We're going to throw things away because our first attempt is rarely correct. So we don't want these big, general, complicated solutions because they're harder to change. We want you to keep it simple so that you can replace it with the next simple thing. And by the way, your guess about the other things you're going to use this code for, probably wrong. Probably no one's going to use it at all for anything other than why you just wrote it. And if they do want to use it for something, it's not actually going to work the way they need it to. They're going to have to change it anyhow. So we see people making this mistake over and over again. Again, this is all tied to Sucker Punch culture and the way we write things and the things we think are important. But for us, it's way better to write a simple solution that exactly meets the problem that you're trying to solve. And if you hit the problem again, just cut and paste the code, do it again. Now, if you did it 3 times, about that point, you were like, okay, well, now I kind of see the pattern. Now I can write a general problem that solves the general problems that I have because I've seen them actually concretely in practice. But before then, don't try to generalize. Don't try to guess what's going to happen next. Just solve the problems you understand. So we kept seeing people make this mistake over and over again. And I would say, don't make that mistake. And they would do it again, right? And the next person would come in and do it again. And finally, this is actually what happened. I said, okay, new rule. Until you see 3 instances of a problem, you cannot generalize it. And it was like angelic chorus. Oh, right? It's like, that was my angelic chorus. Obviously, I'm not going to train vocalist. And it actually worked. It actually worked. Like, they wouldn't do it again. They'd be like, oh, yeah, I don't have 3 examples. I'm not going to generalize this, right? And when someone new came in, I would say, okay, here's the rule. First time I saw him do it, code review or something. First time I saw him do it, I'm like, okay, here's the rule. 3 examples or you can't generalize. And it worked. It completely worked. And I'm like, oh, well, that seems like a good answer, right? Suddenly I have this, not just the rule, but the idea of a rule, right? Where it's like, okay, well, what else is there that's like that? What are the other things I can tell people where I can take some complicated idea, like don't generalize until you have 3 examples, and distill it down into a form that they can remember, right? Where it's like, oh, I get it. I've got this little thing in my head, right? It's like haste makes waste, right? Like an aphorism is what they're called, right? It's a saying that kind of just like distills down some wisdom in this form that you can remember and then hopefully apply. And so I started thinking about all these lessons I was trying to teach new programmers in terms of rules, right? Not because they're real rules, not because they're super hard and fast things where it's like, oh, no, you absolutely can't do this. You have to break the rules sometimes. Everybody does. But you kind of want to know you're breaking it. So you're thinking hard about what you're doing and why. And so we started accumulating these rules about the things we think are important about code and how to write code in a way that's going to work well in the Sucker Punch code base for the sorts of problems we have to solve, kind of distilled down in these easy to remember rules. So like, as simple as possible, but no simpler, right? That's a rule you can apply a lot for life, but it turns out that code's a good place to do it, or you need 3 examples before you can generalize, or, and when I switched to half-time, I decided that I wanted to write a book about this, about the rules that we had and why we had rules and why putting things in rule form was useful, because it makes them easier to remember and easy to apply. And whether or not the Sucker Punch rules are appropriate for somebody else, probably some of them are, some of them aren't, right? That's why there's a whole book, so you can understand what the point of the rules are. The real point of the rules isn't so much the rules themselves, but the idea of being introspective about the way you're writing code as an individual, or the way you're writing code, even more importantly, the way you're writing code as a group, right? Most of us work in groups. And you have to like think about that. I think if you're going to be effective, you have to
Oh
put
yeah.
together practices that let you work together effectively, because you're not working independently. If you are, you're not going to get as much done as if you were all working together.